Hello! We were streaming to completely the wrong location, but now, welcome to this AimHi Live. This is the first one, which is a collab, which means that I'm doing science and Hannah is doing geography.
That's
Hi.
me. Hi.
So yeah, this is a bit of a trial, so let's see how it goes. I know that Hannah's flashing a bit, so you need to tell us if that's annoying or not, because we haven't figured out how to control the flashing yet. Anyway, if this is your first time here, then today we are going to do what continents don't exist yet. Also, NZ Catherine, I saw that you're here as well. I know that you've asked me to do a certain topic, and it's totally in my list, and it's going to happen. But everyone else, if there are certain topics you want me or Hannah or anyone else to cover, do let us know, and we'll cover them. Hannah, you're now below, so if you point up, then that's me. And Jamie Lubica, who's watching on Facebook, fine to watch on Facebook, but if you watch on Facebook, you won't see what anyone else is saying in the chat, so do head to this website if you want to see what everyone is saying. Anyway, should we get on? Right.
Yeah, let's do this.
Let's do this. Okay, and I don't know if Hannah knows the answer to all these bits, because we kind of prepared this stuff slightly mysteriously to one another, because we thought that'd be more fun. So, does anyone know what this is, what this building is? Has anyone seen this building before? What's this? It's a tower, yes. Correct, Miz.
It's a tower from Lord of the Rings.
Okay, so some people are saying Lord of the Rings, some people are saying it's something to do with space. Okay, I'll give you some more clues. This is in Siberia, in Russia, and it's a world record holder.
I've got an idea.
Go on.
Did it survive an earthquake? Was the only tower to survive an earthquake past a certain date or something? Like when it was built? Like it's the only surviving building of... No,
it's not the only surviving building. Simons is saying it's a seed bank. Oh, okay, it's not the seed bank. Hannah, do you know about the seed bank?
In Kew Gardens? No, I don't know about the seed bank.
No, mate, there's a seed bank on Svalbard in Norway, which contains backup copies of all the world's most important seeds.
So it's cold, so it keeps them, they can refrigerate them, contain them, let them survive.
When they built it amidst the ice, they were like, well, the ice will act as a backup, so it'll never get too warm. And then literally within about 5 years of building it, the ice started melting away. Honestly, it's a total disaster. It was flooding because of the melting ice. Right, this is the Kohler. Somebody actually said it. There were a couple of people who got this right.
Yeah, they did at the start. They were saying Kohler. People were saying Kohler.
This is the Kohler borehole. Now, the Kohler borehole is the deepest artificial hole, the deepest like human drilled hole on Earth. How deep do you guys reckon this hole goes down under the ground? This is just like the ceiling tower on top of it. Get out of the freezer saying 3 centimeters. Yeah, mate, it literally goes 3 centimeters down. It's unreal. They
didn't try very hard. They didn't have very far to go.
I think Catherine's the closest with 10 kilometers. Okay, so it goes 12 kilometers underground, which is pretty deep. Anyway, right, I kind of want to get on to Hannah talking quite quickly, so I'm just going to do my bit. I'm going to do my bit. Does anyone know why they drilled this hole? So this is the Kohler borehole. It's the deepest artificial hole in the world, and it's in Russia. Why did they drill it? Does anybody know? It's more than 12 kilometers down, actually. It's about 12.2. Why would they drill this hole? But why?
For glory. For the glory of the Soviet Union.
Okay, so Simaz is saying it would need a pretty steep angle to get to China from Russia. Yeah, because this is the deepest straight down, because there are actually other boreholes that go a bit further. They just go kind of like diagonally sideways. And I think most of them are in the Middle East. Simaz is saying trying to reach the other side, and it's Maggie is saying maybe Soviet Union. Manny Perez is saying you're right, they probably got bored. Yes, exactly. They just got bored.
Border quarantine.
The aim was just literally to see how far they could drill. It was just a scientific experiment of how deep into the ground can we drill. Now, it seems pretty far, 12 kilometers, but did you guys know if you shrink the whole world down to the size of an apple, then how deep into the apple do you reckon the crust of the Earth is? How far into the apple do you reckon the crust of our Earth goes? Seamars is coming in with another classic 3 centimeters. Get out of the freezer, it's 3 centimeters as well.
Is that always the answer? Has that been an answer to previous questions?
It's always 3. Bit lopsided, needs a top hat. Thanks, Catherine, for speaking the truth and the importance of exactly what needs to occur. Leonardo's saying 1 micrometer, and the real Joe, in brackets Maddie, is saying all of it. So there's quite a lot of 1 centimeter to 2 centimeters. But Kieran was exactly right. The crust of the Earth would be less thick than the skin of the apple, and the rest of it inside, or almost the entire of the inside, is liquid. Now, I find this completely unbelievable. For a moment, look down and consider that underneath us, most of the world is this enormous ball of lava that we are on this tiny little unspeakably thin crust kind of floating on top of. You know what, Hannah, let's do your bit.
I feel like that's a good bit of geological structure of the Earth introduction, which is kind of what the actual structure is. We'll maybe delve down a little bit more exactly into this diagram. So does anyone know what type of plate boundary this is? If you've done a little bit of classic tectonic geography / science, then you might already know. Does anyone know the name of it? Oh, Maggie, I'm sorry. Just saying I don't like geography. But do you like science? If you like science, it's basically the same thing. You're like, this is what we're trying to prove, is it's not different, it's the same. Okay, so subduction thingy, yeah. The subduction is important. Destructive, good. Izzy has given us the correct. That's the kind of literal name for it. The technical name is a convergent plate boundary. Oh, Angel got there, Leonardo got there. Great.
Wait, convergent plate boundary. Okay, guys, just for the record, I did not know that this was called convergent or destructive. But I do agree with Hannah. I do agree with Hannah that this is science. I know about it being a subducting plate. So that means that one plate goes underneath the other, right? As they move together.
It.
Okay, cool. That's what I know. Right, carry on.
Why is it called a destructive plate boundary? Why is there so much death and destruction going on at this convergent plate boundary? It would probably rather not be called a destructive plate boundary, but it is. Because the volcanoes. But what's actually, so this links a little bit to subduction. What actually leads to volcanoes forming on this kind of plate boundary?
While you guys are answering Hannah's question, I'm just going to give you some advice. If you do want to become a fossil, like if that's a long-term ambition of yours, then one of the worst places to try and become a fossil would be around here, because you'd nestle in your dead body and whatnot, and you'd maybe set it right up, and we'll talk about how to become a fossil in another live, but it's just a bad spot because you're going to get subducted into the mantle.
You want some nice glacial deposit. You basically want to sit in a river and have the sediment just sort of deposited over you over time, and then maybe get a little bit of, I don't know, some kind of like tectonic pushing down, but not any magma. The magma's not good for that.
Anyway, sorry, Hannah, do go back to your question.
No, they got the answer.
Did they?
But then the fossil chat's far more interesting. The oceanic plate is the more dense plate, despite it being much thinner than continental crust. So that's why when the borehole that Matt just talked about freaked me out, because oceanic crust is only at the most 10 kilometers thick, but continental crust can get up to kind of 35, 45 kilometers thick. So this means that even though the oceanic crust is incredibly thin, it's also much denser, and this is due to the process of how it's formed, and this is kind of what we'll get into a little bit after we've done this game, which I'm quite excited about, but I don't know whether it's going to work. So hence why there's volcanoes at destructive plate boundaries, because this oceanic crust that melts in the subduction zone gets into the asthenosphere, which now the thing you need to remember about the mantle.
Wait, what's the asthenosphere? That's this bottom bit, is it?
This is important, the top bit. So the asthenosphere is actually is not the same as the rest of the mantle. The mantle is kind of this like semi-molten, we don't actually know its consistency, but we do know the asthenosphere is kind of like jam. It's a bit jam-like really thick strawberry jam. And the sort of eggshell type, like Matt was saying, eggshell type crust sits on top of the very, very, still very hot molten jam, a bit like when you take, I don't know, is there a McDonald's reference there that I'm missing? Like an apple pie, and you just bite into the apple pie and you're like, oh my God, it's hot. But anyway, I'm going to basically try to get Matt to draw destructive plate boundary through description, but maybe we could even do it through everyone else trying to describe, but I think the delay might make it a bit difficult. But I'm going to stop and pause and ask some questions at different points so that we can see what we've learned so far.
Can I just say that someone asked if tectonic plates cause tsunamis? You're right, the earthquakes caused by them underwater can cause tsunamis, because that's sudden. Yeah. When tectonic plates suddenly shift, they can shift the water level and tsunami it right up.
The tsunamis are like a column of water because of the energy that comes out of, that's amplified out of the tectonic boundary. it literally explodes upwards and the water has to move, energy has to move somewhere. So it's pretty scary. Right, okay, are we ready for this game? I haven't really been looking at the chat. This is what's quite good actually about having two of us.
I've been loving reading the chat.
Yeah, the chat's been full of good stuff. Okay, so swarm of because those bees don't like but they do like it because there's nice geothermal energy at volcanoes, and actually I reckon the bees might have a nice time during the winter if they were near a volcanically active area.
Okay, right, so what are we going to do? I'm going to draw this again and then people are going to try and name it, are they?
Yeah. We're going to try and name the components.
Okay, but before I do that, the only bits that I haven't labelled is this bit here, which is the continental crust. Now, why is there continental crust under the land but not under the ocean?
That's a very good question. Does anyone know the answer to that? That's where we may need to see the Tharp-Heezen map. Maybe we don't play the game yet. We go to some Tharp-Heezen action.
Right, okay. Before we play the game, because oceans aren't continents. Yeah, but they do fit on a continental plate.
Yeah, on the continental plate, but this relates very nicely to...
what we're doing below. Right, okay, take me on this journey. Let's go.
Right, this is it. It's beautiful. Does anyone know what this plate boundary is called? It's between North America and Europe, and it's the reason why North America and the UK, some of you might think this is a good thing, is moving an inch apart every year.
In case you don't quite know what you're looking at, this is kind of like what the bottom of the ocean would look like if you drained out all of the water. So it's like you've got kind of the mountains underneath, yeah.
Oh yeah, Izzy got it. The mid-Atlantic ridge, absolutely. So this is a divergent plate boundary, so opposite of convergent. Essentially what happens at this plate boundary is that the Earth is moving, the tectonic plates are moving apart, and magma from the asthenosphere rises up through this crack in the Earth. And
wait, so the asthenosphere is the bottom bit, right?
Yeah, exactly. The asthenosphere is the bit below the lithosphere. That's the posh name for the crust, is the lithosphere.
Feeding up the magma. Oh, the lithosphere is the other name for the crust?
Yeah.
Right, okay, because I'm not very good with remembering long names. Crust.
Cool. There's quite a lot of... It's a bit like learning kind of Latin, I think.
So the asthenosphere is the magma. That's all the lava and the magma. Great.
There you go. That's where that magma
Crack
is.
on.
And it cools immediately to form new oceanic crust, and that's why continental crust is really old. It's been there since the dawn of time, and I feel like maybe we need to skip out the game and just flip straight to talking about why the continental crust is really old.
Let's do that. I want to hear. Yeah, I want to hear about that. I also just want to reply. There was a comment. So it was Phoebe saying that she looked up what the sea would look like without water, and the Earth looks all lumpy. It does look lumpy. However, I think I already answered this question on another live, but if you shrank down the whole of the world to the size of a squash ball, so even that squash ball is like much smaller than an apple, you know, it's one of those like black balls that has like two little colourful dots in it, then the world would still be smoother than the squash ball. Even though it looks really lumpy to us now when we drain it, it would still be smoother than a squash ball if it was the same size, because the crust is just so thin. Anyway, sorry, carry on, Hannah.
Basically, this is why this movement of tectonic plates is the reason why the continental crust itself is so old, but also this links nicely to something we know of as Pangaea. And we didn't really know Pangaea existed until around like 1908. Alfred Wegener, bit of a good guy. So Matt, do you know what Pangaea is?
I love Pangaea.
Yeah, I feel like you need to talk about Pangaea.
So basically between these two, this is this plate boundary that Hannah was just talking about, and these plates, so here's the one on the left, and this isn't all one plate all by itself, but we'll just pretend it is for now, and here's the plate on the right, and these plates are moving further apart, and I think it was maybe Maddie or Izzy, I can't remember who just said it in the chat, about how this is a divergent boundary because they're moving apart.
Yeah.
Is that also constructive? Because then all the magma's coming out of the world and forming new crust.
It's constructing new oceanic crust, exactly. All oceanic crust is formed at this kind of plate boundary. All of it is the magma rising up and cooling into these lovely pillowy lava bubbles.
I remember finding that so cool when I first realised that shape just perfectly fits inside there, and you can literally see how it's all moved apart and how the UK used to be part of like Maine. Anyway, right, okay, so
puzzle.
Before I talk to you about Pangaea, I just want to take you on a journey to this place here, which is a country beginning with G. Does anyone know what this country is called? Incoming countries.
I don't want to answer, but obviously I want to, because I want to prove that I'm a good geographer. Because that's what everyone thinks geography is, just knowing where things are.
It's not Ghana, but it does begin with G.
I think you've drawn it a bit far south.
Have I?
So,
Nah.
are you thinking of the country I'm thinking of? Is the
Gabon.
question. Yeah, it's a bit south.
Is it?
That's Angola. You've put a cross on Angola.
Have I? So yeah, Gabon has beautiful white sandy beaches. Anyway, the reason I wanted to show you Gabon is I just wanted to show you this little bit here. Firstly, has anyone seen this picture before? This is something completely crazy. These are the remains of a nuclear fission reaction. Why would there be the remains of a nuclear fission reaction in the rocks of Gabon, of Mr. Naro?
It's really spooky, this. When you told me this, it gave me that like feeling that things weren't as they seem. We weren't in control of a lot of things, you know what I mean? That feeling.
See what? Because a nuclear fusion reaction occurred there. Yes, Kieran. Miz is saying aliens. Yes, thank you, Miz. Thank you.
Finally, some sense.
Finally a chance to speak for the aliens. No, it's not. Russians? No. Boomers shoved in some aliens. I'll wait for a few more guesses to come in. But also, just to say, thanks so much for coming on this journey with us of doing a collab. We're really interested to know, like, what do you think of it? If you think it's good or not. Because...
they're giving us too much airtime is the question.
I'm really keen to do more of these because it's really interesting for me to like find out some of the stuff that Hannah's teaching. I think it's really important for us to understand more about other subjects, and I've ended up doing more and more of science, but I need to get better at other stuff. So I'm going to do one as well next week, I think, with Phil, where we're going to talk about a piece of bacteria that's had something really crazy printed onto the inside of it, and now it's replicating that information over and over again. Anyway, we'll talk to you about it later, but that is going to be pretty cool. Okay, so Marin is saying, is it volcanic batholiths? And that, I think, is exactly what this is, if I remember. I feel like I recognise that name, although I can't remember the technical name for it. So Kieran is saying maybe two tectonic plates hit together so hard that fission occurred. So when things hit together really hard, that's when you're kind of pushing towards fusion if it's hard enough, but you would need like the mass of the sun to make that happen. But no, the impact of tectonic plates is not going to be enough to make this happen. Oh, there's some really nice things being said on the old chat.
Yes, it's lovely.
Anyway, okay, right, I'll tell you what happened. So this is a nuclear reactor that set itself up by itself naturally underground 1.5 billion years ago. 1.5 billion years ago, this reactor set itself up underground, and it continued to react on and off for hundreds of thousands of years, just dissipating heat into the surroundings and so on. There are some theories about how this could have contributed to life evolving faster because, you know, you've got a little bit of radiation spilling out into the surroundings, but hundreds of thousands of years you've got this reactor just going off underground, which could have been the Soviets, but they would have had to also have gone back in time, which would have been really impressive. And if they did that, or if anyone did that, then fair enough, you know, because that's pretty fair enough. Anyway, right, okay, let's talk about Pangaea as promised.
Okay, so that relates a bit to how you were talking about how people are trying to find ways of disposing of nuclear waste, right? This is what you mentioned earlier.
Ooh, yeah, I totally forgot to talk about that.
If you go back to the diagram, our first diagram of the convergent plate boundary, I feel like these two things come together quite nicely because it's pretty exciting.
Hannah has reminded me of my plan. Thank you, Hannah. This was exactly what I was going to tell you about. I just forgot. I see if anyone can put all the pieces together themselves. There is a plan of how we can get rid of all the excess nuclear waste, which brings together this deep hole that I was talking about, and it brings together this, and it brings together this subducting plate. Can anyone think of a way that we might be able to get rid of all this excess nuclear waste that is building up that we know is very dangerous to be keeping at the surface? What could we do?
Then we can
Enzo
all have
Catherine
nuclear
saying
reactors.
turtles, no. Get out of the freezer saying put all the nuclear stuff in the hole. The hole's actually really narrow. So the core borehole is actually quite narrow, and so you wouldn't be able to fit much nuclear waste into it. There are other ways of getting rid of nuclear waste. Like if you put nuclear waste underwater, then the radiation literally does not travel through the water. So as long as it's in a very solid form, then underwater is actually quite a good place. But realistically, when you're talking on the timescale of thousands of years, like your storage is going to could get destroyed. There are ways of turning nuclear waste into glass, but anyway, I'll talk about that another time.
I feel like that needs to be a whole live. I want to know about that because there's a lot of stigma attached to nuclear energy, and it could be a pretty decent solution to reducing CO2 emissions.
So Izzy is saying drill it really deep into a subducting plate. Exactly. So if you can deposit nuclear waste deep in a plate that you know is on a course where it's traveling down into the mantle, then we could literally take all of the uranium that we could possibly do a nuclear reaction with in the entire of the crust, turn it all into nuclear waste, and then if we put put it all into the mantle, the mantle core of the Earth is so big that it just wouldn't even notice the fact that we'd added what seems to us to be a large amount of nuclear waste. Or at least that's what I'm saying now. And but then, look at what happened to the ocean when we kind of assumed that the ocean could just always take all of our waste, and then it couldn't. We probably still have to be cautious about even this. But still, this is a good way of getting rid of nuclear waste, potentially.
How would you test it? Do you know what I mean? How would you test the scale of the impact, like what it could do, right? There's a lot of unknowns, surely.
There are unknowns, yeah. But it is, at least it's something that's being considered and talked about. Hey, people are celebrating that we got a view bot in the chat.
What's a view bot?
We got a bot advertising in the chat.
Because it means you're famous.
Yeah. Anyway, right, we need to start wrapping this up. So I want to
finally talk about Pangaea.
So just to talk to you about these two last things. So this is called Pangaea, which I'll probably spell wrong, but I think it's
No, go on. You go.
A-E-A?
You do it. That's it. Scrub that out.
Pangaea. Okay, anyway, so the Pangaea kind of sounds like Pangaea, because Gaia will be like the Earth, and then Pan is like one altogether, togetherness. And so Pangaea was when all of the continents of the Earth were all connected together into this huge, great supercontinent that was around at the time of the dinosaurs. And so they used to be able to wander freely between South America and Africa before that plate started opening up in between and creating the whole of the Atlantic Ocean. Hannah, what could you talking about evidence for this?
They've literally found fossils of land reptiles that are exactly the same in their, their carbon dating, their diameter, like the exact same animal in India and Africa. So there's this whole band of fossils they've tested, and the same between South America and Africa as well, where they found all the same animals that existed on Pangaea. It's crazy. The one between India and Africa looks a little bit like a giant pig. It's called a Lystrosaurus. And then they've also tested the age of rocks, the same band of rocks that goes across South America and Africa. There's so much evidence to show that this existed, but Alfred Wegener was the guy who initially, he saw the jigsaw puzzle, so he saw the shape of the continents and thought, that looks too good to be true. Why do they all fit into each other? But if you look at the bits in between, Matt, if you like these little bits in between, that's a little giant pig. That's a bit like the great film called Okra, which is the same guy, director as Parasite, and it's about a giant pig that they try and save. I don't know why I'm plugging that film. It's just a great film. To answer the question of what continents don't exist yet, why is it that new continents could exist in the future? What process is happening I'm asking everyone now, that means that we might have new continents in the future.
And while everyone is answering that, I just want to say to shout out to anyone in New Zealand, because that was going to be another bit that we were going to kind of talk about, and I'm not very good at drawing New Zealand, but anyway, we'll just kind of draw it like that. Shout out to anyone in New Zealand to say that a lot of people argue that New Zealand should be its own continent because it's kind of on its own plate by itself, and people propose that it should be called Zealandia. And so that is kind of a continent that...
I didn't think of a better name.
It's a continent that kind of exists now but hasn't quite been given its own continent name. That's a pretty cool continent.
Has anyone remember the name of the plate boundary? People are saying lots of good things about...
Tashdor's saying other continents break up and then crash together.
But where do we get where is the new crust formed? That's what we want to...
Leonardo's asking what are the places with no names. So the places with no names might be things that have been destroyed or disappeared.
Yeah, they are. They're bits of the crust that subducted at our destructive plate boundary.
But we've added them to make it make sense.
To make it make sense. That they used to be there, now they are gone.
Yes.
But some of them have been absorbed underneath different plates as well. There's like bits that overlap that used to be tectonic plate boundaries.
Other continents break up and then crash together is a great answer. And then Enzo Catherine's saying crust movement. Miz is saying they can come from the ocean, so you can get new volcanic ones forming. Yeah, these are such good answers of why other continents will form. Now, I think we're going to have to end this because we're running to time now. But although we did say this one would be slightly longer, and I think it's fine for the collab ones to be longer. Before we end, so Pangaea is called a supercontinent because it's all the continents together in the past. But we now think that about 5 times longer ago than Pangaea, there was another supercontinent called Rodinia. By looking at how the plates are moving and running different models to guess about where they might have been before, and also looking at other evidence to do with not just fossils, but to do with the different kinds of rocks, we think that actually the Antarctic, which is here, India and Australia and Madagascar all used to be in the north of the Earth. They used to be in the north of the Earth and somehow have kind of travelled like over the top of the Earth, because India is travelling upwards, so it's kind of gone over the top of the Earth, round the bottom, and then up again. India's travelling upwards, which is why it makes the Himalayas, because it's crashing into the Asian continent. Australia's gone all the way around to chill on the other side, and then Antarctic has obviously gone all the way over the top to end up on the bottom again. And then
didn't that used to be called Gondwana? That bit was called Gondwana, wasn't it? That moved. It moved in a really weird way, like you say.
What, this whole bit?
Yeah, it's all called Gondwana.
Yeah, I've heard of the continent Gondwana. I did not know that it was that bit. That is cool. Gondwana is a great name. But yes, anyway, we should we'll finish off here. So thanks so much everyone for coming. Here's what's coming up next, in case you are keen for. So this is later today. We've got why the colour blue doesn't exist. Will Brexit end the EU? And those are both. So that's later today. In fact, Hannah, you're back later today with Will Brexit.
Back later today. I can't get enough of it.
And Phil, who I'm doing the collab with next week, is on at 1 in a few hours. And then tomorrow we've got Is Inequality Wrong? Are dinosaurs overrated? And are different cultures becoming extinct? And then
massive questions.
Yeah, thanks all for coming. If you're on the website, we need to update this form, but Phil, give us a bit of feedback on the feedback form if you want, or just let us know now how you found this, because we would love to get your thoughts, because if you like this style, we're going to do more of these, because I thought this was really fun. And yes, also, how big a problem is it that Hannah keeps flashing? Because I'm yet to figure out why that's happening.
Well, it's not flashing. It wasn't flashing that much for me.
Oh, good,
I'm paying attention, but
cool. I think that's it. Go to the website to join the mailing list, so that you can get the weekly sketch, and follow us on socials and tell your friends.
Thank you, everyone.
From
lovely time.
AimHi Live. Right. Are there any last questions that we should answer? I can't see any because the chat is scrolling so fast. I think this is it.
Someone said R.I.P. Thanks, Kieran. Or you're Kieran. I'll see you tomorrow instead. Or you'll be asleep.
Clab is sick. Thanks, Kieran. Right. Farewell, all.
Bye, everyone.
Farewell.
Someone's cleaning my window.